Hello, everyone. Good morning, good afternoon, good evening from wherever you are in the world. Again, welcome to Filecoin Core Devs Call number 62. Today being Thursday, October 5, 2023. We have a light agenda, I'm hoping, today, but obviously very important discussions to have. Super Snaps discussion by Nemo and Jake. We also have the aggregate signatures in FEM by Nemo and Jake as well. And Jennifer will jump in quickly to walk us through NV21 Watermelon upgrade updates. And that will be all for today. So without further ado, I'll pass this now over to Nemo and Jake. I'm not sure. I believe they're on the call.
Yes. Oh,
Great. Take it away.
all right. Greetings, everyone. So, thank you for scheduling us for today's meeting. Our team, Phil Crypto, we recently introduced two FIPS. We just wanted to present them here to kind of get the ball rolling on a broader conversation. We had posted the FIP discussions for these drafts previous to publishing the drafts. But we wanted to keep it in the forefront of everyone's mind. We'd like to propose these at some point in a future protocol upgrade. And I know that there's still some discussion or some possibly contentious issues that need to be resolved. So yeah, I just want to thank Jake for making these awesome slides for both Super Snaps and the BLS Aggregate Verify. And he actually volunteered to speak to the slides today. So with that, I'll actually hand it over to Jake.
Okay, thank you, Nemo. I'm Jake. Hi, everyone. So Super Snaps, it's a FIP that basically takes snap deals, which is currently you have a storage provider. They have an empty sector of data called a CC sector, which is used to commit data to the network without actually having user data in it. So that's snap deals. Basically, it's how it's how you add in new data, actual user data into that CC sector, that empty sector, that committed data on chain. Super Snaps is a way of aggregating the Grot16 proofs, the snarks that prove that you updated an empty sector correctly. So I guess from the diagram, basically the way snap deals works is you have a CC sector, which is just a sector of empty data. You seal it, you get a replica out of that. Then snap deals allows you to mix or add in, overwrite some of the empty data in the CC sector with actual data. So it's called a sector update. You get a new sector, new replica out of that, and then you have to prove that you did the update correctly using snarks. Grot16 is what we use, Grot16 proofs. Due to the size of proving that computation, you actually have to generate 16 Grot16 proofs to actually prove that the sector was updated correctly. And then you would publish all of those proofs to the network, and they would verify those proofs. That snap deals as it currently is. Super Snap is basically the same thing, but when you get to the snark phase of publishing, rather than publishing each snark individually, you can aggregate them into a single proof that's small and easy to verify. It's more efficient than if you were to verify each snark individually. So rather than publishing and verifying each proof individually, you can use a snark pack to aggregate the proofs, have a single snark pack proof, publish that to the network, and it's efficiently verifiable. A cool thing about Super Snaps is you don't have to just aggregate the snarks for a single CC sector update. If you did multiple updates for multiple sectors, you could aggregate all the snarks into a single aggregate proof and then publish that, and then verification is efficient for all of those proofs. And for the gas, it's kind of small on the graph, but I guess if you were to verify the Grot16 proof of each snap deal's Grot16 proof individually, that would be linear growth. It would be a constant increase in total verification time for each proof you verify. For using SnarkPack to verify aggregate proofs, you have a logarithmic growth in verification time, and thus logarithmic growth in gas cost for an aggregate proof, snap deals message. And the crossover point between where non-aggregate verify time for non-aggregate proofs and aggregate proofs, the crossover is 3 proofs for snap deals. So if you were to aggregate 3 snap deals proofs into a single snark, which is like 16 times 3 is the number of Grot16 proofs you're aggregating. That would require less gas for those messages, the message, than if you were to publish all those snarks like individually and stuff. So I think that's everything for super snaps. Grot16 aggregation for snap deals proofs is what it is.
If I could just add one thing. So what we're actually proposing with super snaps is you can think of it in terms of like the workflow, where some storage providers, multiples, have lots of CC sectors, and if they had an incoming pipeline of data, they could actually like do all of the updates, add all of the data at once, and then aggregate all of the proofs so that we have a single proof that lands on chain, which can be verified that like all of the data across all of the snap deals was entered correctly. The goal, of course, is to save on chain bandwidth.
Thank you. Yeah. I think if that's it, next slide, please.
Yeah. Do we have any question from anyone for Jake and Nemo before we move on to the next item on the agenda? No. Very quick question before we move on. Do we know any Andrew Jackson? Is that someone?
Yes.
Yes, he's from the Lotus team.
Okay, just wanted to make sure. Right, so moving on back to Nemo and Jay.
Apologies. One more thing on the super snaps. So please, we're looking forward to feedback in the FIP discussion, if not later in this call. Thank you.
Yep, there are FIP PRs and FIP discussions already in like the Filecoin project's GitHub for both these FIPs, the previous one and this one. So just they already exist. So you can just go look at them. They could be sorry.
I guess I actually have a question with regarding to the super snap. So last time we chatted, we're also talking about for the other aggregation and messages operations on chain, we do have a batch balancer as like, you know, safeguard on the chain usage and gas costs and so on and so forth. We also said batch balancer has its own design, you know, thinking like design like trade-offs that we are discussing these days. So where are we at for super snap from a crypto econ perspective right now?
I'm less familiar with currently what's happening with batch balancer. So if anyone else knows, jump.
No, all I would say there is that yes, there are some issues with the batch balancer as it is. In the current model, this would probably have similar issues. I believe that there are other proposals at some point that will try to address those issues. And at that time, this would have the advantages that it should be having, just like other forms of aggregation.
The gas graph that was in the previous slide, that would be without any like modifications from the batch balancer. So I guess for all of the gas slides, they're not factoring in like the changes made to gas costs by the batch balancer. Okay. If there's no more questions about super snaps, I'll do FBM BLS aggregate signatures. So this is a FIP that kind of does exactly what the title says. It's adding BLS aggregate signatures to FVM. Currently, FVM supports two signature types, elliptic curve DSA, digital signing algorithm using curve SecP256K1, or just SecP256K1 signatures, sometimes what they're called, and BLS signatures, which is a different signature algorithm using a different curve, BLS 12381. And so those are the two types of signatures currently supported. They are both non-aggregate signatures, meaning you just have a single signer, single message, they sign it, produce a signature, that signature is verified, and then you verify using the signer's public key, the network can, which is like encoded into their address on the Filecoin network. So that would be like a non-aggregate signature. An aggregate signature scheme is one where you can have multiple signers, each signing their own message, and then those signatures produced by each are aggregated into a single signature, kind of similar to super snaps, where all the Grot16 proofs are aggregated into one proof. Same thing basically for signatures. So then, if you had multiple private keys signing each a message, aggregate those signatures together into a single signature, which is constant size, which is cool for BLS signatures, is the aggregate is the same size as individual signatures. And then an aggregate signature could be published as normal and verified using all of the signers' addresses or public keys, whatever you want to say. So this basically, it takes the BLS signature scheme already supported in FEM, but just allows aggregation as well. And the gas usage, this is kind of just projections based on the aggregate verification equation versus non-aggregate for BLS. But it should be more than, or like to the gas cost to verify an aggregate signature versus to verify each individual signature if without aggregation. The aggregate signature verification gas should be half to less than 2/3 of the gas for the gas to verify each signature individually. That's just like using the verification equation for BLS aggregate signatures because it's more efficient than verifying each individually. So it should be about half, less than 2/3 of the individual gas cost. So yeah, so that's it. It's a pretty minor change to FEM because BLS signature is already supported, but yeah, so you get this extra feature at like no real cost. So okay, that's it for that slide. Any questions? Yeah.
Question time. Anyone? Great, looks straightforward, I believe. Okay, we have a number of questions in the chat box. Where is it supposed to be used by? And then, are there any trade-offs or downsides? What's the use case?
The downsides of BLS aggregate signatures, there's none, because like you can still support non-aggregate signatures, just you now have aggregate at cheaper cost than individual verification. Like adding aggregate signatures doesn't increase the gas cost of non-aggregate, as far as I know. I haven't like rerun all the total BLS FEM benchmarks for gas, but it shouldn't. So you basically just get this cool property where you can have multiple signers sign multiple messages cheaper, added to FEM, like cheaper gas-wise to FEM than currently exists. So there shouldn't be any downside. I don't think. I don't know. I've just started working on FEM, so and the use case, I mean, it's basically that to allow aggregate signatures. Stephen Allen, who's like I think one of the leads on FEM, if he's on this call, he might know better than me, but my understanding is essentially to support, aggregate signatures in FEM.
I can explain some of the motivation. The primary motivation was the fact that we had two somewhat strange ways of validating signatures. We had a sort of low-level way of validating SecP signatures by recovering the public key, and this is sort of the standard syscall you have in the EVM. But then we had a more like general purpose method that was for validating Filecoin signatures, but didn't actually expose any of the primitives for validating sort of arbitrary BLS signatures. So the goal here was that instead of having this kind of like weird asymmetry, make these methods symmetric. So instead of exposing like one high-level thing, one low-level thing, expose two low-level signature validation methods, and it just exposed more to the user, so that later, as we add more support for native actors, we're exposing like the most useful features directly instead of like exposing some weird abstraction on top of it, since we were exposing before. That was the main goal. This can also be useful for things like potentially like account abstraction, stuff like that. If you want to like have like off-chain message batching and stuff like that, that kind of thing might actually happen here. Like we already support this kind of thing on-chain, but you might be able to get even better speed-ups. But that's kind of the future thing.
Yeah, I guess I should mention that like BLS aggregate signatures, it doesn't change any of the current FEM like API interfaces syscalls or anything. It's like an additive change. I mean, it removes technically one of those low-level syscall things from like user space, but it doesn't change currently any like user-facing APIs, which is cool. There's just like another API for aggregate signatures. So that's one thing too.
Effectively, it moves a little bit of logic from the FVM and into the SDK. So anyone who's like using the FVM's SDK to just build native smart contracts like won't notice this, or native actors won't notice this. But it just means that effectively like some of the logic that would otherwise be in the FVM now executes a little bit in WASM first and then calls a lower level primitive in the FVM itself.
Thanks. Are there additional questions or? Yes, we have one more. I have a question for the previous topic. I think that's super snaps. Is it possible to unify all snap pack usages so that in the future, if we want to snap pack something else, there is no need for a big change? Sure. Okay.
Oh, sorry. Yeah, I mean, I guess Jake, you could take that too. But as it is right now, SnarkPack is an aggregation technique for Groth16 proofs. Right now, we expose through the proofs library a way to do that with PoRet proofs, and this would add for the sector update proofs. We don't have a way to do those things for something like window post yet, but if it would make sense, then we could do something like that. Right now, at this exact moment, I don't see necessarily a future for saying like this is an aggregate, like a PoRep, 10 sector updates and 5 window posts, like as a single proof. It's just kind of hard to specify that, I think. But I suppose it's a possibility.
I was just going to say, when you use SnarkPack to aggregate Groth16 proofs, those Groth16 proofs that you're aggregating have to be for the same like computation being proven. So like 32 gigabyte SnarkPack proofs can be aggregated with other proofs of the same circuit like computation. And then like, so you can only aggregate proofs of the same circuit or computation that you're proving too. So that's it.
Thanks. Okay. Go ahead. Great. Thanks. Last call for additional questions. Anything else? No? Jennifer, are you ready? Okay, so I think we're moving on to the next item on the agenda. Updates for NV21 Watermelon upgrade. Over to you, Jennifer. Take it away.
Right. Hi again. For those who I have met in Field Dev Summit, I think it's many of you. Thank you all for coming. But because of the Field Dev Summit, it did distract us some of us a little bit away from NV21 development. So we have some changes onto the final timeline for shipping this upgrade compared to what we projected about like a month ago. So the high level timeline that we have right now is the Watermelon upgrade is we're gonna co-freeze for Actor next week, Tuesday, October the 10th. We are still finalizing some like details. We are asking Actor maintainers like Alex to review some of the PR we landed like months ago for fixing the snap sector up start epoch bug. We also like Venus team is still adding more tests for the move petition fit into the Actor. However, we're very close to the finish line. We have been doing a lot of the testing in the Lotus team. So we're hoping to have the Actor and FVM co-freeze next week. And that being said, given that the Venus team currently is having their Chinese national holiday and they will be back next week, we are proposing the calibration upgrade to be on October the 19th, which gives Venus team a little bit more time to prepare their release for their users to join the upgrade. Also, the current timeline, we already synced with Forest team, and I believe they think the timeline looks doable for them as well. As you all can see, we do have a relatively like larger gap than we used to have between calibration upgrade and mainnet upgrade. currently, we are proposing the mainnet upgrade to be happening on November the 28th. A couple constraints that we have. First is like we're introducing a lot of like storage provider operational features into this upgrade. We do want to give people more time, including sitting as a service provider, to test on calibration and give us feedback to make sure everything looks good. Also give more time for the storage providers to upgrade their setup and new configurations so they can enjoy the features like synthetic pull wrap. Sorry, my phone. Synthetic pull wrap and also the move petition features as soon as the network launches. And also there are some constraints with some of us that who works at Protocol Labs or under the Protocol Labs network ecosystem, that we're having a week-long lab week in November, which we'll be talking about exciting development in the stack we're building, but that also means a lot of traveling for us. So we expect reduced capacity during that week. And after that, there's the US Thanksgiving, which a lot of people will be away. So with everything considered, we're proposing November the 28th as our mainnet upgrade. That should give us enough time to testing, giving community also enough time to testing and update their node. And also that is before almost like 3-4 weeks before the winter holidays. So we as core dev, we do have a full month to monitor the upgrade monitor the network post the upgrade to make sure everything is okay. And then we can enjoy our winter holiday later on. So next slide. Oh, sorry. Any questions on the timeline? I know I just proposed that yesterday. So questions, concerns, call out. Yeah, I think Hubert from the ChainSafe team had a good question on Slack. It's like whether this will impact our NV22 pre-scheduled upgrade next year. I don't necessarily think so. Again, all the plan, we should still be working towards that. We have two implementers should have a sync soon to realign on the scope based on what are the FIPS in line, but I don't think we should change that for now. Okay, seems like there's no questions. So next slide. So we can you refresh the slide, Lucky? Thank you.
Give me a second.
Sorry, I added that a little bit last minute.
No problem.
Yeah. So as you all can see, this is the final scope that we were able to implement as implementers. So we are including FIP 52, which allows users to extend their have sector and deals commitment up to 3.5 years instead of 1.5 years, which is the current maximum. Since the pull up from Field Crypto team, thank you so much, Jake, Nemo, and Volker for shipping that. This is going to be reducing the disk spaces between different stages on the Sealing pipeline for storage provider. We're seeing very promising result. I'm pretty sure a blog post is about or just went out. So if you're interested what things that pull up can do, please go take a look. Venus team and Alex has been working on this features that literally I got the request 3 years ago, which is allowing storage provider to move petitions based on their operational schedule in practice. So we are super excited for that one. FVM team is landing. Hi, Lemon. Sorry, the dog is yes, there. FVM team is also landing a couple FIPS this time. So deterministic state access, improved event Cisco API. We are also removing beneficiary from the self-destruct Cisco, and also the FVM randomness FIB. Yush presented a couple quarter back. We are able to test and ship those. So what changed since last quarter? If you remember, we did propose to include a direct data onboarding work in this upgrade as well. However, during the Field Dev Summit, we do realize there are more design discussions need to happen before we can fully accept it from accept it for the Filecoin network. Also, we kind of missed the governance timeline on this one, and that's why we are postponing that for the next network upgrade. However, I believe it's all our interest. We get a lot of good feedback and good questions at the Field Dev Summit about the implementation and the design for direct data onboarding. It's one feature that we heard great feedback from service provider and data client. They really want that for the Filecoin network. So the implementers and FIP authors on this effort, currently, I think it's our priority to actually continue developing a direct data onboarding, and hopefully we can ship that for our network participants in NV22. So that's one of the FIPs that got postponed. And as mentioned in the last core dev, because of the tight timeline, we also postponed the DRAM switch to the QuickNet and to NV22, and also the longer term market crown fix into the next upgrade. I do want to recommend the implementers and core devs to prioritize the implementation and engagement in the design for these 3 initiatives so that we can get those out of the door next year in Q1. I think that's it. Any questions, concerns, feedback?
I have a quick question. How does this affect NV22? How does the change in NV21 timeline affect NV22, if at all?
I said that about 1 minute ago. I think we don't, because it's our first tryout about pre-scheduled network timeline. I think we should still commit to that. I don't think there's, from engineering at least perspective, I don't see immediate feedback other than we have to work harder in Q4 and ship those things.
Sounds good.
Okay, that's it. Thank you.
Great. Thank you so much, Jennifer. All right. And I believe we have come to the end of our call today. Talking about pre-scheduled upgrades, I have opened like series of discussion threads within the, the core devs repo. So if you have ideas or thoughts up to NV25 that you want to, start like discussing and sharing ideas, feel free to engage in those threads. I would also link them when I'm sharing the materials for this call. So if you have thoughts for NV22, 23, 24, 5, we have threads open for those if you want to engage. Yes, Jennifer.
I saw Caitlin is online, and I know there's a lot of great conversation happened around Filecoin governance and core dev in the Field Dev Summit. I'm wondering if she want to give an update or anything that she wants to share with the rest of the group, and also the community who is watching this recording.
Yeah, hey Jennifer, can you hear me?
Yes.
I have really poor service right now. Okay. Well, hello from Phil Vegas. Yeah, so at the last 2 Filecoin Dev Summits, first in Singapore and then in Reykjavik, we worked through many hours of discussion about what is being proposed for Filecoin governance, how we think we should be improving the FIPS process, talking through what the spec for on-chain voting might look like if this is something we want to experiment with, and also exploring what it might look like to diversify or decentralize expertise away from just core devs when it comes to really complicated governing decisions. I think we've had some really real conversations, questions about maybe having tiers of different kinds of security FIPS, really good amounts of skepticism. And I actually think this is a good push. I'm still traveling, unfortunately, but we'll write up this afternoon. I should have time to write up a write-up of what was discussed, and we'll add that to our existing discussion post on GitHub. We're still on track to open the official PR against FIP1 by October 15th, and that will be really the most visible public record of the exact changes that I would like to see, that the Filecoin Foundation is willing to support, and we have their FIP, and also walking core devs through it in the next call in greater detail as well. But yeah, as always, please, if you're interested in this, if you have questions, concerns, I think most of you on the call were able to participate in at least one of those sessions in Singapore or Iceland, which was really valuable. So thank you for doing that. And we will continue to try and stay on top of communications and all of their many pathways and forms.
Thank you so much, Caitlin. Network was a bit wonky, but I think we got the message. I would also include additional details in the notes as well. All right, thank you all so much for joining, and see you all next month for Core Devs call number 63. Have a lovely rest of the day or the night. Goodbye.